Hi everyone, welcome to my video. If you have been following my previous video, you know that I am doing a course of Munger University syllabus. So in this video, I will discuss semester 5 MSc paper Physics 8 Element of Modern Physics. So come to the point, course outcome here you read and you see what you find. I find this is particle property of radiations, black body radiation and Planck quantum hypothesis, discovery and explanations of photoelectric effect, component scatterings, pair productions and annihilations, wave aspect of particles. Idea de Broglie wavelength and matter wave, Dyson-Germer experiment for a diffraction of electrons, J.P. Thomson experiment and phase velocity wave, Picarian concept of velocity, wave particle duality, concept of wave particle duality, Heisenberg uncertainty principle, uncertainty relations involving canonical pairs of variables and their derivations, from wave packet estimations of minimum energy for a confined particles using uncertainty principles originals of the natural base of emission lines. Uncertainty principles and concepts of the orbits.
Conclusion of Unit 3, Chapter 3, Atomic Structure, Introduction of the Summerfield Quantization, Rules, Bohr-Sommerfeld Atomic Theory,
Explanation of hydrogen and hydrogen-like spectra. Comparison between H hydrogen and He helium plus spectra. Correction for finite nuclear mass and corresponding variations of Rydberg constant. Relativity corrections. Unit 4. Wave mechanical descriptions of electron particles. The Schrodinger wave equation property concept of normalizations of wave function. Expectations of value Schrodinger equation for non-related particles. Conceptual operator in quantum mechanics. Time independent Schrodinger equation. Probability problem equivalent velocity idea of energy. Eigenvalue in eigenfunction. Unit 5. Fundamental property of nucleus, size constraint and structure of atomic nuclei. Idea of isotopes, isobar, isotopes and mirror nuclei. Mass defect packing fractions and binding energy, energy per nucleon versus mass number curve, stability of
The nucleus and nature of nuclear force.
law of radioactivity, decay, mean life and half-life, successive radioactivity disintegrations, basic idea of alpha, beta and gamma decay, idea of energy momentum and priority conservations in a nuclear decay process, Q value in a nuclear reactions, and radiation detector ionization chamber, Giger molar counter, neutron detection spark chamber, bubbles, clouds and oscillations, Chernobyl radiations. So here she is suggesting quantum mechanics as C. Verma and MC Jain, Satya Prakash, Jagatak as well as. So come to the point. Semester 5 MSc paper 9 Basic Electronics. So credit 5 theory is 2, practical is 2. Course outcome this. So come to the point. Basic Electronics. Digital circuits. Difference between analog and digital circuit. Binary systems decimals to binary and vice versa, and or and not gates. Realizations using diode and transistor, NAND and NOR gate as a universal gate, XOR and XNOR gate. Basic circuit operations, De Morgan theorem, Boolean's law, simplifications of logic circuits using Boolean algebra, fundamental product, miniterm and maxterm conversions of a truth tables into a equivalent logic circuit by 1 assumption of product method 1 and Carnot map for advanced learner. Combinational circuit, basic idea of a binary addition, binary subtraction using two apostrophe s complement, half and full adder, half and full subtractor. Next you say semiconductor device, PN type semiconductor
energy level diagram, graduate formation in a PN junction diode, qualitative idea of can follow mechanism in forward and reverse based diode PN junction and its
characteristic state and a dynamics resistance principle and structure of LED light emitting diode, photodiode, Zener diode, and solar cells. Electronics device and their application rectifier diode, half wave rectifier, full wave rectifier, central tapped and bridge, calculation of a ripple factor and rectification efficiency. To voltage regulations using Zener diode, bipolar junction transistor, and PN transition, PNP transition, characteristics of CB, CE and CC configurations, Pentagon's alpha and beta parameters, and relation between alpha and beta parameters. Common base, CB common base, common emitters. Load line analysis of transistor DC load lines and Q point. Physical mechanism of current follow active current and saturation region. And amplifier basing circuit and stability, fixed bias and voltage divider bias circuit of common emitter amplifier as parameter equivalent, input and output impedance and current, voltage and power gains, class A, B and C amplifier for advanced learner. For operational amplifier, black box approach, practice and ideal practicals OP MP IC 741, open loops gain CMMR, concept of a virtual ground, application of OP MP 1, inverting and non-inverting amplifier 2, adder, subtractor, differentiator, integrator, feedback and oscillator effect of positive and negative feedbacks on gain and stability, distortion and noise, sinusoidal oscillator, Barkhusian criteria of a Barkhusian, self-sustained oscillations, RC and wind bridge oscillator, high physical unit, instrumentations, instructions of the CRO block diagram and application of CRO, a study of wavefront measurement of voltage, current, frequency and phase difference, power supply, half wave rectifier, current trap and full wave rectifier, and full wave rectifier, calculation of ripple factor and rectification efficiency, basic idea about capacitor filter, Zener diode and voltage regulations, timer, IC 555 pin diagram and its application as stables and monostables, multi-vibrators. So you see this practicals, the major voltage band, time period of period wavefront using COR. So this is also read. So I hope so that is all related to this discussion that is for today. Thank you very much.